So now that I've completed my end cuts and my brace, what I'm going to do next is actually plan out how these footings are going to sit and the connection between the post and the concrete sonotubes. So in this particular case, and in your drawings too, you should be doing this all the time, is the center line that we originally created or generated from the four posts are extended throughout the whole project so that we're always working off the posts. As mentioned to you before, once they've located the four posts, all the other numbers come from those posts. You can't arbitrarily change them. So here are my conditions where I've got a post sitting on an existing concrete column over top of an existing beam. So these are beams. And I have another beam, and there's the other post. So these are posts on beams that then sit on the concrete column, and those are the deck beams. Then I've got this one down here, which is a post that sits on an independent concrete column, no beam. And then I have this one where the beam extends past the concrete column by a foot, 3 3/8, and the post sits on the beam. So those are the three conditions. So the one I'm going to be drawing is this one down here, where I have the post sitting on a beam and the concrete column is offset, and this one here where it's completely independent. And so that's what I got to keep in mind when I'm working with this. Now I've drawn my sectional elevation. So at 8 feet, I've got my blue deck. The deck boards I'm using are 5/4 inch or 5/4. So I've offset that 5/4. And then I've taken the top line and offset that 7.5. That's my deck heights that I've decided to work with. Remember that it's a step and you can't go greater than 7 7/8. So 7.5 is a good size. I could have gone with 7/4 if I wanted to. So that's the distance between the top of the upper deck to the top of the lower deck. It's 7.5 inches. And then once again, 5/4 boards. And then I've placed in some of the joists that are going to be in the project because the beam sits on the joist. I'm using 2x8s for my joist and my beam. You can just see the top of the beam, and then you can just see the bottom of the beam. So the beam thickness or the height of it is based on the calculations we did much earlier in the program. So I've already offset those lines. So now I've got to determine, how do I connect all this? How is this all going to work together? So this first post sits on top of the beam, but the actual column is offset. So I got to keep that in mind. What can I do to help me with that? I'm going to take this drawing here and I'm going to copy the different elements. So there's that, there's this, and there's that. This is the independent one. Okay, so I'm going to take that. There's my base point. Zoom out, pan down, and then make sure it's perfectly aligned. There it is. And that's my two conditions. So this is my plan view. There's my top view. These are the concrete columns. So I'm going to take the outer edge of them. That is the quadrant from here. Extend that straight up. I'm in the wrong layer. Thought I switched layers. Obviously, I made a mistake. I've got a pergola concrete layer. There we go. And I want to make that current. Good. And then I'm going to copy this from that location to this location. Okay. So that, the way it sits right now, that is the width of the concrete column. Okay, I've got that already here. I might as well copy that over. So I'm going to copy that over from the center point of this column to the center of this. So I know where my two columns are. Great. This post sits on the beam. The beam sits on the column. Okay, so what do I know? Well, I know a couple of things. First of all, I know that my footing, and each of these will have a footings, and we'll talk about footings a bit later on. The footing has to be at least 4 feet below finished grade. There's my finished grade. So I'm going to offset by 4 feet this line, and it's always the top line. And now I know the distance to here, my actual concrete column. There we go, and there we go. The concrete column will support the beam the beam supports the post. Great. Okay, so this line is just a temporary construction line. What about these footings? So when we're creating footings, we're going to be creating a footing that's 8 inches tall, and the footing will be 2 foot 2 inches wide. Okay, so I'm going to select offset and type in 8. There we go. And it's 2 foot 2 inches wide, but I don't know how wide my columns are. I'm going to take a center line from the center straight down. They're 2 foot 2 inches wide, or offset 1 foot 1 in both directions. So we have this direction, we have this direction. Now I got everything I need to make my actual footing, and the footing is a rectangle that goes from there to there. And I don't need those lines, and I don't need those lines anymore, where those were just temporary measurement lines. And I can fillet all of this together. And fillet that to that. Oh, that's a rectangle. I don't need to fillet them. There we go. And there's my actual post, my concrete post, and my footing. Now I'm going to copy that. Now I can't go from center to center because the centers are at different heights. But I can go from the edge of this concrete column to a point perpendicular to the edge of that concrete column. And there we have our line work. Now, it just so happens when I copied and pasted it, I did it the right way. And so the extension of the lines matched. So there it is. And this also shows me the fact that that concrete post, or the wood pergola post is offset from the center of the concrete column. So those are all critical things. So now I'm going to look at how am I going to attach all these things together. Well, we have two different types of attachments. Those are the Simpson strong ties that we're going to be referring to. So I'm going to reach over here where I've gone ahead and already drawn this. And those are my two different types of Simpson strong ties I have. So this one is post to beam, and this one is beam to concrete column. So I'm going to, like I said, I've gone ahead and cheated here. I've already got this drawn, so I'm going to use that and place it here. Now, it sits right here, but it's supposed to sit in between those two lines. So mid-between, I go from there to there, and there we have the connection. So let's try to understand what it is that we've actually drawn. This post here, let me trim that off to its right length, sits on top of that beam here. That's the beam. So that post ends right there. It's sitting on top of this gray beam. Now, I have a different type of line type just so that I can see it broken up here. I'm going to pull those back together so you can actually see what happens there. This plate connects that post to this beam. Awesome. But we have a different connection here. And that connection is our connection between wooden beam and the actual sonotube. So this line represents the bottom of the beam. But this particular Simpson strong tie has a 1-inch offset. And the reason being is we don't want wood sitting on top of concrete. That could create all sorts of problems with moisture. So we leave that the way it is. Make sure that we have a nice offset. I'm going to pick the midpoint of this thing. And I'll go to that intersection, and then I'll simply extend this line right across to there. And now I can trim to the top of the column these excessive lines. There we go. So we have successfully shown our concrete sonotube sitting on top of a footing. It's using the Simpson strong tie to connect the top of the concrete sonotube to the base of the beam. And then we're using another Simpson strong tie to tie the post to the actual beam itself. So I don't show the line coming through here. I'm going to switch to the pergola structural line, and I'll place it here just so that I can see it. Now, sometimes those lines disappear. They get hidden underneath each other. So what you can do at any time is, in this particular case, I always want this red line on top of the beam line. I'm going to click on it, right click on it, and there is an option in here that says draw order. We're always going to bring that to the front, so I always see it. So that, therefore, it won't disappear. There's a lot of other line work here that is sort of interfering with what we're doing because it's the deck and everything else that we've got drawn here, and we'll be removing those lines at a later time. So I've got this one drawn. I can leave that. I no longer need this. This is no longer necessary, and there's all our connections that we're going to be working in this case. Now I've got this one over here. This one's different because this one is an independent sonotube that is supporting this particular framing member. Okay, there's a couple of rules we should keep in mind. The concrete portion should be exposed about 6 inches, 6 to 8 depending on where you are, but 6 inches. So I'm going to make sure that I did just that. And that's how I determine where that grade line is. And there it is. There's your 6-inch gap right in here. So the beam itself comes down. It comes 1 inch below that is the top of the concrete, and then 6 inches below that is the top of grade. That's how you determine where grade is. So the grade will, in this case, always be 7 inches below the beam, in the worst case scenario, because the beam heights are going to be different. And it's going to be at least 6 inches of exposed concrete. And that protects the base of the beam from getting wet, whether it be from snow or anything of that nature. So that's where I know my top of my sonotubes are, right at that location. Okay, I don't need this line anymore. I will copy that from that position to this one here. There we go. And now I'm going to connect the post to the concrete. It's a different type of connection. And as I've done before, I've already selected it. This PDF, or sorry, this DWG file comes right from Simpson Strong-Tie. So I'm going to copy that from there, and I will paste it here. And that's what's going to be supporting the post. The post itself is offset, once again, 1 inch. There's my offset. And now I can fill it. My post. My post. And I no longer need the top of that sonotube to extend past that edge. And I no longer need this diagram here. Okay, let me just leave that up for a second. Now, why do I bring that up? Well, the question is, how big is this sonotube? Okay, a lot of it has to do with this post. So if I measure the post from here to here, 7¼ inches. It's an 8 by 8. Okay, if I actually measure the sonotube itself, there to there, what do I select it? I selected a 12-inch sonotube. Now, why did I pick a 12-inch sonotube? This distance in here, I'd like to have a minimum of 2 inches. A minimum of 2 inches. And sonotubes come in 8, 10, 12, and so on. They're at 2-inch intervals. So the 12-inch sonotube was ideal for a 6-inch post. And as long as I also am working with, in this particular case, a post of that size, I don't have to change the sonotube size at all. The footing, in our case, is always going to be 2 feet, 2 inches by 2 feet, 2 inches by 8 inches deep. That's what we're always going to be working with our project. And that's typical of anything where it doesn't have a roof. When we actually do a gazebo, and it has a roof structure on it, we have to calculate how big that footing is. But that's what we're going to be using for our purposes here. So this worked out to be perfect for our example here, for what we needed. And there we have our 2 different scenarios. Post on beam, beam within a couple of feet of the sonotube. That's this condition. This one, independent post, right on top of a sonotube, and that fulfills our requirements right here. Post on beam, beam on top of sonotube. Here, post directly on top of the sonotube. So let's take a look at my other condition. Remember, the plans that I have here drawn are at a 45 degree, or sorry, are at a 90-degree rotation from one another, which means that this post in sonotube configuration is the same as this one here. And this post in offset beam is the same as this one up here. So this one that I'm looking at the bottom right-hand corner is the same as this condition here, which in this case, it's beam on top of sonotube, and the post is on top of the beam. So everything's centered, and that's why I've got it drawn exactly the way I have here. And I've extended that one line, this line here, to run through the center of the post, so then I understand the conditions that are below. So I'm going to do the same thing where I'm going to copy this information here and that one there, straight down to this location here. And the other thing I've done is this. I have originally a beam that runs between different sonotubes that are for the deck construction. They've got nothing to do with the pergola. This one runs on top of it. So I've also drawn this right here. This is the beam that misses the pergola configuration, whereas this one sits right on top of it. So I can take this and copy this right over because that's my scenario. And I'm using my beam structures that I have calculated earlier in some of the exercises we were working on. So mine happened to be 4-ply. And because this doesn't play a role, role in terms of the construction I've graded out, whereas this one does. So I'm going to take that and make it part of the actual structure. So it's a structural component. You can see the X's through it. And so we're going to have a Simpson strong tie for that. And we're going to have a different type of Simpson strong tie for this. Now, in this particular case, you'll notice that the footings, more or less, this is the same footing. And the Simpson strong tie is going to go in the opposite direction. So I can easily copy this. Now, I'm going to take along the Simpson strong tie just so you can see it. And I will copy it from the midpoint between 2 points here. Sorry. Made a mistake. Let me try it again. Copy this and all of this. Great. From the midpoint between 2 points. Then that. And I'm going to pick off the center perpendicular to the center here. But this time, this Simpson strong tie is rotated in the opposite direction. So what does that look like? Again, these are DWG files. They're available right from Simpson strong tie. And it looks like this. So you can see the two profiles. It's basically a U channel. So in one direction, it lies flat on the two sides, and those are all the holes that you can screw in place, whereas the other one, it simply has an opening. And the reason it has an opening, and you can see it right there, that opening there in here has your 1-inch offset, and it also allows the screws to only go in one direction, and it's slightly short, so the post has a slight overhang, a drip effect, so that when the water comes in, it basically can drip off the wood and doesn't settle underneath the metal framing. There's a lot of engineering that goes into stuff like this. So I'm going to take this one and replace it with this one, and I'm going to pick the midpoint down here and tie it right there. So let me get rid of this. I don't need it for this example. And I'm going to see if I can change the color to black. There we go. And my post in this direction, and these are slightly wider, but that's okay. When you screw them in place, it fits perfectly. I will take that post layer and I will draw a line That comes off of that. And now I can fillet that line to here and that line to there. And there's my post sitting on that pocket that then sits within the actual sonotube, just like this. Perfect. So I've completed this one. It's done. What about this one over here? Well, what kind of post configuration does that have? Basically, since this post is sitting right on top of the wood, we're going to frame it in place and simply drive some very large screws directly in it. There are some plates that we can put in to reinforce it, which is this one rotated on 90 degrees, but it's a flat plate, so you don't see it. So you'd make a note, but you really don't see that particular configuration. So I will copy this and that, this and this from that center line perpendicular to this center line. And then the beam connection is another Simpson strong tie. I've already determined which one it is. And I found it right there. And I will copy it from here to here. Again, those are all elements that you're going to be locating online. And these are all DWGs that are available to you so that you can download them, copy them, and use them in our project. Okay, so I've got a bit of an error here in terms of the height, so I will move that and this down so that it lines up with the top of the beam. I don't think I moved it straight down, so let me try it again. It happens. That and this from there to there. Usually when I make a mistake and I repeat it, I just zoom in on it ever so more closely. And let's see if we can change the components of it. I would have to explode it first to change it to black. Okay, so the post, what is it sitting on? It's sitting directly on the beam. So the post is on the beam is on the sonotube. Okay, we got to reflect that here. My post is slightly wider than the beam. That happens. Okay, so I will draw my line work there. And I can then trim to that line my post. So there's a bit of an overhang here. Now, there are considerations when we're looking at stuff like this. What sizes are allowed, where the building department may or may not ask you to shore some of this up. So it may ask for a piece of strapping that comes on the two sides, just so that we start with one width and go to the other. Other the building departments, depending on how much of a change there is, they won't be quite as stringent. So it all depends on where this project is being built. And so that becomes important information that you're going to find as you discuss it with the building department. Now, it almost looks finished. There's one last step. There's one last step that we need to do, and that is to brace the pieces. So here, it's easily seen. All it is two of the floor joists. I'm going to copy this, and they snuggle right up against the actual posts. And I'm going to show these in red. So when they print out a bit darker than the ones that are there, just to show the builder that those two are structural blocking. They're to support that post. And we have the same on the other side. So now I can copy this and this from the center line here down to the center line there. Okay, so that shows the blocking in that direction. What about in this direction? Well, really the blocking here are the joists. So the joists are just doubled up. to frame out the actual post. So I use the term blocking, but really it's a doubling of joist. What we really have on the other side is true blocking. It's only the width or in between joists themselves, and they will be shown here and here. So you can see how the base of the post here is supported slightly up from the very bottom of the post, where the bottom of the post here is right on top of the wood. And so that's why we need a Simpson strong tie connection here. And then we can block it up as well, or sometimes in here, because of the blocking method we're using in our connection, we don't need to put in that Simpson strong tie. Sometimes they'll put in a dowel, or maybe just leave it just as is with some nice long 4-inch screws that are screwed right in from the post to the beam. What we're trying to do is really resist lateral movement. This thing, because of the weight coming straight down and everything centered, it's not going to go in any direction other than somebody maybe kicking out or hitting the base of the post. So we're trying to stop lateral movement. That's what we're doing. And then the deck boards, you can see I've shown the deck boards above are just floating in there just to show you how the direction of the deck boards. So the deck boards are in this direction, therefore the joists are in the opposite direction. We're down here, the deck boards run the long width, and therefore the joist, you see the ends of it. If I take a look at all this, and I drew that just so you can see it, this is my final diagram where I'm going to ghost out all of the decking. So whatever's existing, I ghost it out, because then it becomes very prominent how we're going to frame into that deck and what each of the elements are. So the last thing that we're going to do once that's done, I've done that over here on this side, is complete all the dimensions throughout the entire project so that it's ready to be inserted into the viewports of our L3 and L4.